Now coming to the different modes. Okay, so we know about the communication transmissions method, but in which mode they are doing this transmission? Okay, they are doing the in two ways. Okay, two ways or two modes are there. Okay, so one is the synchronous transmissions and another one is the asynchronous transmissions. Okay, first we will learn about the synchronous transmission. Okay, this is an efficient method of transferring the large block of data. In this mode, before the data is sent, the sender and the receiver first is synchronized with each other with the digital clock signals. Okay, what do you mean by the synchronization? That both the sender and the receiver must agree with some protocols or some rules. Okay, maybe they said I will send three blank signals, and after three blank signal, you whatever information you are getting, that is actually the real one. There must be some sort of agreement between the sender and the receiver must be there. Okay. Okay. Only after sender and the receiver is synchronized. Suppose 12 o'clock they will send. They have done an agreement that at 12 o'clock the data streaming data transmission will be start. So whenever they get this notification, they will its receiver will start giving the data and sender will receive the data. Some sort of. Okay. So. So this is similar to making a telephone call. So like a caller dials up the number and forms a connection with our caller number, then start the conversation. After the conversation is over, both the person disconnect, but the connection remains active till the full conversation is over. Till the data transmission is going on, it is active. But as soon as the transmission be received by the receiver, then and sender also done with the sending of the information, both the end it will be they will be disconnected, but the connection is exist. Okay. Okay. Now coming to the asynchronous transmission. This is refers to the transmission of information between two devices that are not synchronized with each other. There is no agreement between them. Okay. So it means any of the clock signal or any other mechanism. Okay, so they are not actually synchronized by any clock pulse or any signals or nothing. The sender can transmit the data at any time while the receiver must are ready to accept the data when it's arrived. So sender must be alert mode. Okay, when receiver sender don't know when the receiver will start the transmission. So it may be in the alert mode. Right now the data will come. Right now data will come like this. Okay. Any point of time sender can send the data and the receiver must have to receive the data as soon as it arrives. So that's why in this transmission, this kind of a transmission occurs using the data packets. From the beginning, when I started the chapter networking, I have told you that in case of network, the informations are actually passing as a data packet, small packets. Okay, and usually is used for the serial communication. Okay, so how actually this data packet is designed, I will show you. Okay, and how the data packets occur. Okay, I am using a different color. Okay, I am using the blue, yellow one, that will be helpful. Okay, how the message is going. Okay, I am designing the window. Okay. That one is the S bit. S bit means start bit. Okay. Now is the actual MSG. MSG means message. Now is the parity bit. Parity means the I'm telling, and the stop bit. Parity means they're pure. Okay. Parity is there, and now is the stop bit. Okay. Where to stop? Because it is a packet. So they have to denote the end of a packet. Packet after packet they are sending. So this bit will denote that is the end of the packet. Then there will be a idle time gap. Okay. After then again start bit, again MSG, again parity bit, again stop bit. Okay. This total thing as named as data packet. Okay. So what will be there in the data packet? I hope you understood. Okay. So parity bit is what actually check. It's a bit to check if any error is there in the transmission, any transmission errors is occurred, because when it is coming in a packet, maybe one packet received earlier, maybe some packets are missing, maybe the information may be missing or something. So that's why one parity bits are there that includes to check if any transmission error is occurred or not. Okay, I hope you have understand this these things. Okay, transmission. Now coming to the differentiation between these two. So clock pulse, in the first form clock pulse subject, the transmission and receiver share the common clock pulse, but there is no common clock pulse present in the asynchronous transmission. Speed of transmission in case of synchronous is fast, and in case of asynchronous it is comparatively low or slow. What we get sent. For form of data transmission, data is sent in the form of frames or blocks, and data is transmitted in the form of bytes or characters. Time interval, it is constant, it is variable. Okay, cost is very expensive, synchronous one, as they have to synchronization has to be stayed and then the transmission. Okay, comparatively less expensive than synchronous one. Okay, time interval, it is a constant and this one is a variable one. Okay, why vary? You don't know that after one data packet will receive in how many times, you don't know. Then first after the first data packet there will be interval, so you cannot count that after 10 minutes one packet will be received, then will be 5 minutes delay, then the second one. No, you cannot count. That's why it is variable. Okay, efficiency, synchronous one is the most efficient one, and compared to the synchronous, asynchronous is less efficient. Need of external clock, it exists in case of synchronous, but asynchronous no concept of clock pulse or clock signals. Okay, need of start and stop bit doesn't exist over here. Okay, but in case of asynchronous, start bit and stop bit is required. Okay, and circuit is more complex in case of synchronous one and comparatively less complex in the asynchronous system. Okay, now we will learn about the different transmission, that is the baseband transmission and the broadband transmission. So first we will learn about the broadband transmission. Okay, so data transmission speed at least 256 kbps are termed as the broadband, that we are using, like broadband internet connection. Using broadband communication, the information is usually sent over multiple channels, thereby increase the overall bandwidth. Hopefully you understand the concept of the bandwidth now. So however, bandwidth channels transmit analogous data are unidirectional in nature, meaning both way, okay, at the same time. Okay, hence two different channels are needed for the transmission of the signals in two different directions. Okay, so what are the characteristics? I am saying that is the analog signaling is there, transmission is unidirectional, signals traveling distance is long, frequency division multiplexing, that I come just after that, this one I will explain. Okay, so transmission of a multiple signals over different frequencies, and used to they like example like TV we are doing now, TV premises, TV that we are broadcasting everything, that one is a broadband. Okay, now come to the baseband. It's a digital signal transmit the medium using the signal code like NAR, NRZ, Manchester Piper's encode is a very hard term for you right now, but just to remember that this refers to the situation where the entire bandwidth of the communication channel is used to send only one digital signal. Okay, and the baseband channels are the bidirectional in the nature. Here digital signal is there. Okay, frequency division multiplexing is not possible over here. It is a bidirectional as I mentioned. Okay, shorter distance signal traveling is there. Okay, entire that means that I am telling. And now example is that Ethernet we are using in LAN, that one. Now come to the difference between these two. Type of signaling, baseband is a digital one and broadband is an analog one. Application is, it is worked with a bus topology and it is can be was bus as well as the other topology as well. Encoding use, Manchester differential Manchester encoding is there, and here it is PSK encoding is there. Transmission, it is a bidirectional one, this is a unidirectional one. Signal length, signals can be traveled over a shorter distance and signals can be traveled well, over the longer distance without any attenuation. Attenuation is not required over here. Now come to the different part, that is the frequency division and the time division multiplexing that I'm talking about in this previous. Just now I have talked about this different. So first we have to understand what is the meaning of the multiplexing. Okay, so multiplexing is used in the case where the signals of lower bandwidth and the transmitted media having the higher. When you are transmitting the signal, that is in the lower bandwidth, but where you are actually transmitting, that is having the higher bandwidth. Okay, so in this case, the possibility of sending number of signals is more. In this, signals are combined into one and sent over a link which has a greater bandwidth of the media than the communication nodes. So now, coming to the different type of multiplexing. First one is the frequency division multiplexing. In every end, the different frequencies are used to carry different signals generated by each transmitting device. A multiplexer is used, you know the use of a multiplexer. Okay, so a multiplexer is used to modulate each carrier frequency with an input signals and then transmit them simultaneously across the channel. So it will take several signals and transmit to the required destination. At the receiving end, the demodulator will be there, or the multiplexer circuit will be there. Use the exact data signals from the different carrier frequency. And the in the diagram you are able to see this one. It will taking the multiple inputs and then it is transferred to the multiplexer, as well as it is reached to the destination, and one demultiplexer will be there. They will extract the from which carrier the which frequency and coming, and according to that they will send it to the channel. Okay, now coming to the time divisional frequency. In TDM, a particular pre-assigned time slot is assigned in each transmission node. The total time available in the channel is divided between the several users. So each user of a channel is allotted the time slices during which it may transmit its data. Thus, the several data streams are joined serially to form a signal data stream and get the transmitted. Okay, here actually baseband concept is used. Here time slot is there. Okay, one time slot is for this channel, second time slot is this channel. In this way, it is given. Thank you, students. I am ending my lecture over here.